Hey dosto, let's see about thermodynamics, and we are going to be done here introduction about this thermodynamics, and we are going to be in a very brief and in a short while and overview on important points only. So when we talk about the thermodynamics, it is a single word of two different things. There is one is thermo, which represents the temperature and the energy, and dynamics is the motion. So basically we can say that it is a science of energy which transfers and the effect and its effect on the property of the system. So basically this is a science of energy transfer and its effect on the property of system. When we uh, start this study of thermodynamics, so basically there are two types of studies. One is microscopic and another is a macroscopic approach. So in thermodynamics we will go through the macroscopic approach, that is called classical thermodynamics. Classical thermodynamics where the scientists have found out the empirical formulas. So when we proceed further, there are some basic definitions one has to be understood. One is what is the system and what is the surrounding. System is that thing, it is a reason where we concentrate totally the space upon which we concentrate and we study, so that is called the system. And the surrounding is that external to the system, means there is one, suppose imaginary boundary is there, whatever is outside to that, outside to the system, so that is surrounding, where we concentrate and the space and we study, that is system, and outside that it is a surrounding, and what it makes a difference to the system and surrounding, that is what boundary. So the separation between the system and surrounding is a boundary. So if you see this table, uh, a system, energy transfer and mass transfer. So there are three types of systems. One is closed, one is open system, another is isolated system. So we have to be categorize which one is energy transfer and means whether it is a energy transfer, means it's allow energy transfer or not, it allows mass transfer or not, that we have to be same. So the first system is a closed system. You can consider any uh, closed system. uh, Generally in a book, if you see, uh, they give many examples for a closed system. Suppose there is a, you know what, um, piston cylinder, but that doesn't have a walls. Walls are closed, so that is a closed system. So in that case, energy transfer will be the, obviously there is, and mass transfer no. But when you take the example of open, so any control volume, suppose there is a room, for that room you have a there is a door is also, there is window also. So from door, so that air takes place, and window, that is get out. So in that case energy transfer is also there and mass transfer is also there. But when the third system is the isolated system, isolated is a system where energy transfer is also not allowed and mass transfer is also not allowed. So for that, basically the famous example is that perfectly, you know um, insulated thermosplast. Okay, perfectly insulated thermostat means where is a there is no scope to be energy loss, and obviously there is a no mass transfer. So these are the three types of systems, and we have seen which one is energy allowed transfer and mass transfer. Okay, so let's move further next to the poor substance. What is poor substance? Poor substance is a substance, you know what, for which the chemical composition throughout its volume is constant, there will not change, and for that phase system there is nothing to do with the, there is no relation for the pure systems about that phase. So phase has nothing to do with the pure substance. A mixture of ice, water vapor is also poor system. Let's be further about thermodynamics. Before that, I will like to tell you related to this pure substance. Yeah, I hope that you have gone through the Gibbs law. Gibbs law, what it tells, it gives a formula C plus F is equal to P minus 2. C plus F equal to P minus 2. So mm, that was the formula. From that one can find out the, if you want to check a number of phases, then one can use that formula. Let's we further go uh, thermodynamics equilibrium. So what is thermodynamics equilibrium? So basically there are three main categories. One is thermal equilibrium, one is chemical equilibrium, and another is mechanical equilibrium. So if you see concentrate on the word of equilibrium, equilibrium means equal and opposite. There is a, you can say, a reaction means there will nothing will happen. Um, there will always equal and opposing force will be there to make it you know constant. There will not be occur any process for that. So if you see thermal equilibrium means there is equality of temperature. Chemical equilibrium there is equality of chemical potential, and equilibrium is equality of force and pressure. These things will not be proceed there. Then property of a system. If you go to the property of a system, uh, all the properties are characteristics of systems. There are basically two types. One is intensive system and another is extensive system. Intensive system is also called intrinsic properties, and extensive properties also called extrinsic properties. So intensive properties, those properties which do not depend on mass, and extensive property are those properties which depends on system mass of a system. So if you go through the example wise intensive systems, examples are temperature, pressure, uh, volume. These are the example of intensive properties. In the extensive properties, entropy, density, all these are extensive properties. And one is the important point is what all the specific properties are always intensive properties, and the ratio to extensive properties also intensive property. Keep it these two red color uh, points. These are very important. And properties are state functions. They can also call the point functions. Point functions is where we take a consideration of the first point and the last point. And the path function is that where we take consideration the whole process from starting from to the end of the point. So these properties are independent of path function. They are dependent. They are point functions. Then we will further move towards thermodynamic cycles. When the initial and final points are same, then the system is said to have undergone a thermodynamic cycle. And minimum number of processes required for the cycle is 2. And changing property of thermodynamic cycle is equal to 0. Then change of state is known as process. If you want to show as this process, change of state is called process. Then there is a very important point: what is reversible and irreversible process. Reversible process is the process if once the process takes place, and if it come back again following with the same path without leaving any effect on a system and surrounding, that is called a reversible process. And reversal process is a very most efficient process, but in an actual case if you see all our existence process in real life are not reversible process, they are always irreversible processes. And what is the irreversible process means the same. So the process which is not reversible, once it further proceed means proceed. So there is nothing to go back with the same path. So due to the presence of friction between the two surfaces, that is the example, that process becomes irreversible. You can't go back and recover the frictionless condition. So this is how